I want to share with you today in this webinar all the tips that you can, how you can speed up the development of deep learning models in MATLAB. So I have a lot of tips. It's good for you to take notes, and if you have any question, just use the chat. So in the chat, you can post the questions. We have a team of engineers here in this call. They can answer the questions on live, okay? At the end of the presentation, I will answer the questions from the chat, okay? So please post your questions at the time you have it. And what else? This presentation is being recorded. You will have access to the video probably after a few hours after the finish the presentation. I will share with you other channels that you can get the videos, and also how you can request the code that I will share. I will share as PDF this code. Okay. So I will try to use. I'm using actually images and data sets directly from the MATLAB documentation, so you have access to it. It's public data. And also Python, you know, you have Python. I will show you how to integrate Python in MATLAB in a few steps. What else? Okay, that's all. Thank you. So let me get started with this presentation. Okay, I will shut down the video because I have a screen here. Okay. Very good. So the idea of this webinar is to explore these numerous ways in which MATLAB and Python can collaborate, demonstrating co-execution capabilities and showcasing practical applications with AI libraries. So the idea is, it's not MATLAB and Python, they integrate themselves. So you don't worry. What you have in Python, bring it to MATLAB. What you don't have in Python and you want it, bring MATLAB to Python. You can do both, okay? Let me see, let me click here. Okay, so the agenda is within the MATLAB live script. So there you will see that I did these changes. Let me just show you. So here you will see the same structure of the agenda, okay, by links. So you can click in this live script and it's going to take you directly to the area, the part of the code that has everything, okay? Just let me clear all my outputs and we're going to do it live. So call Python from MATLAB. It's for you to set up the Python path, the calling user-defined functions in Python, running scripts, running MATLAB. It's good for you to see the data exchange between Python data types and MATLAB data types. Importing TensorFlow networks. So here starts the deep learning library. So we're going to use TensorFlow and do co-execution. Different ways to call TensorFlow models. Also PyTorch are included here, and how you can export them using this ONNX format. Okay. So maybe you know. Okay, I know MATLAB from university. This maybe was last year or was a long time ago. Okay, so MATLAB can talk to everything. Okay, so here's just a picture that you can integrate data sources with MATLAB, business systems, dashboards, cloud systems, virtual machines, devices, edge devices, so anything. Okay, here we're talking only with Python. Okay, so it's very important when you start your project to talk to your IT infrastructure team and see what is going to be my data source, what is going to be my business systems, my dashboard. Do I need to run this when this code is ready? I need to run it on production. How how many concurrent calls I will have from this code. Millions of times in a second, so you need to measure all of this, okay? Because by having these answers, you'll be able to get the data source, the cloud system that you need to process, and the dashboards also, okay? So today we're gonna talk about Python. But also if you have other legacy code, for example, C, C++, Java, .NET, you also can call MATLAB directly. So MATLAB can call these functions and you can run it. In this case of Microsoft.NET, you have DLLs. Okay, so this is all in the documentation. When you open MATLAB, go to other programming languages and see how MATLAB behave, how it connects with other languages. Okay, don't need to transfer all your code back to MATLAB. Use the code; it's the legacy code. The idea is to speed up the development with MATLAB. It's made for engineers and scientists. So something I will talk about is this ONNX. So it's Open Neural Network Exchange format. So we will do this TensorFlow importing. We're gonna do also the PyTorch is not here, and also the ONNX can be in here. PyTorch is here, okay? But now there is a direct to PyTorch to MATLAB, and other exchange models if you want. There are 3 ways to integrate MATLAB with Python. Okay. Let me just click again. Okay, calling Python from MATLAB. That's what we're going to do today. Okay. So our idea is to show Python running within MATLAB, and calling MATLAB from Python. This is also possible. It's something that I will show you in a few slides later, but will not be covered today. We can cover another session. And the next one is packing MATLAB programs for scale deployment with Python. So also you can package your MATLAB code into Python packages and call these Python packages within Python. Okay, so when you create your package, you just import the package. It's that straightforward. Okay, let me just go directly to the demo, and after we'll cover the calling MATLAB, Python, packing, and more. Okay, let me just go to my code. So I have a live script, and this will be shared with you. You need just to send an email to us. I will give you the instructions at the end of this webinar. So the table of contents, we went through it now. So call Python from MATLAB. Let me just make it bigger here. So this is a very important step to connect Python and MATLAB. It's important for you to add all the environment variables path in Windows in this case. So go to your environment and include the Python path this way. Also, you need to know where exactly is the installation of your Python executable here. So they will change this version. So Python can run, I think now we have 3.11. It runs since the 2.7, okay? So the location of my executable is in my users folder, app data, local programs, Python, and executable, okay? So be aware of this. When you run this command, for the first time, it will tell you, I don't have the executable, so you just need to provide a flag of the executable where exactly it is, okay? So you see libraries, home, and everything there. In this folder also you should have the libraries. Okay? The libraries are in some of the libraries here, NumPy, SciPy, or they are in this. Let me just go there in the Python, libs, and site packages, I believe, when you do the installation. Okay. If you need any help, go click on Py environment, help. It's going to open this summary. And so we have the Python interpreter since 2019b. You open the documentation and it's gonna tell you all the instructions you need to follow, okay? So Python version, executable. If you're facing any problem, go to this documentation and try to run the executable, or where is the location. Tell at least one time where is the location, okay? Let me just go back. So here is my MATLAB. There is a process ID. This is very important when you are running MATLAB within Python. It's very important to have this process ID, okay? But today we're not using it. Now, how to import libraries. You know, when you go to Python, you do the pip install NumPy, and you install NumPy, you install SciPy as well. So these will be, the libraries will be placed in one folder within this Python, and you can import using this function. So import lib, import model. So let me run this code. When I click here, I'm running the same as run section, or control enter also. So NumPy, you see NumPy is for matrices. So it's a module in Python, and we have many functions. So you can see that all the functions here, types, more modules inside, and you can see there are many functionalities. So you can see all of them. At the end, you will see where exactly is NumPy located. So it's local programs, Python, lib, site pages. NumPy is there, okay? SciPy the same, so you can also bring all the modules, the functions there. But if you want to bring only few functions, for example, here I want to bring only the linear algorithm. I don't know where it exactly is here, but I can call this way. SciPy dot the model I want to bring. So now it brings only what is inside that model. Okay, you see it's less content, and it's exactly inside the SciPy. There is another model called linear algorithm. Okay, very good. So take notes of this, how to import it. Later you can try it. So now how to call Python built-in functions. Call Python functions, just use the py dot notation, okay? So anything you need to call, py dot, and the inside the module and the function. So here I'm doing a test. So I will run Python, square root of 42, and also I will use MATLAB answer, square root of 42. If you run this, you still have the same result. There is no square root, is only one thing. If you go to the workspace, you'll see that both are here, both answers, the Python and the MATLAB, and they have the data type of double. Now we go to, let me make it larger again, this. So you can create Python data structures inside MATLAB and call Python methods to them. For example, here I have a structure, sorry, a dictionary in Python. I create as a structure, and after I just want to call the value of A. And here you see that we have the input is Python list. So you're using Python list data type. You also have the structure, and also you can get the answer from the structure. Okay. For since the 2022A release of MATLAB, you can call everything the same way you do in Python. So using the equal, okay? Equal instead of comma and parameter. It's very important to know the data type that Python accepts. Not all data, Python doesn't accept every data type. So in this case, the integer 8 will be the input. For example, here can be single double MATLAB. Okay, so here what you're doing. Hello world. I want to have a wrap of 2. So we're getting 2 characters. Hello world here. It's very important for you to see the data types. There is a table inside the documentation how to see the data types, okay? How to see the conversion of them. Now I want to call user-defined Python code. So I have a script in Python, and I want to run this script. So let me just show where is the script. It should be inside my, here inside my directory, weather script, Python. Okay, this is the script. So you see, I have functions in Python, and you have the code for run. Okay, so it's going to, there are W and inside here Boston, and Boston's going here and return the location and display the temperature for this location. But also there is another variable called T. So let me just go back to the code. Also you can see the Python code inside MATLAB. See the definitions of functions and the correct color of them. And let me just run it. Okay, so you see it's very fast. I just run it by run file and provide the name of the file, and it runs. I can run it again, you see, very fast. So it's getting a random temperature, random number between 0 and 20. Okay, but also you want to get other values from this. So I want to get only T out of this script. You can provide in this way. So capture outputs from the script. Find run file, the name of the code, and T. So in this case, you're gonna have the output T as the temperature, okay, as the value in a separate value. If you go here in your workspace, you'll see T as the double, as the MATLAB output. Okay, very good. So this was the basic, okay, with Python. There is a lot more to explore. Always go to the documentation, help. It's gonna open this small window. You can go here and see, but also you can make it bigger and explore what is a file, what are the outputs possible. There are MATLAB always, when you click, takes you to the documentation, and you have examples and how to get the outputs, okay? Now let's go for the TensorFlow network. So now we're going to the libraries, AI libraries. So you can import pre-trained TensorFlow network in the safe model format. There is this object here, or you can have the extension of TensorFlow, that is PB. PB stands for protobuf. In TensorFlow, the protobuf file contains the graph definition of the network as well as the weights of the models. Okay, so in this case, let's get let me just open here. So I have a folder called digits net here. Okay, and here I have the safe model PB. Is the protobuf. Okay, so I can just tell what is the name of my folder, and now here we have the function. I want to import TensorFlow network. So you provide the model folder. The output layer will be a classification and the classes that you provided here. So this is the digits one. So I have 0 to 9 outputs. Let me just run it. And also you will plot, simple using plot of your network. You'll be able to see the network. Okay, very fast, it's there. So importing safe model is here. If you go to the plot, you will see how is the network. You can make it this bigger. You see, I have one input, and the convolution layers are here, and back to concatenate these layers and a classification. And if you want to know more about the network, it's very good that you click here on the net workspace. Inside, we'll be able to see the layers, the connections, inputs. This is very important for in the side, this format, that you can see the connections. Layers, you can go to layers, and here you see the layers of the network. Convolution layer, you can go there. You're interested about the weights, are here the weights. Okay, so it's already a trained network. So you have values in the bias as well. So you can navigate in MATLAB easily through the intermediate steps of anything. You can just debug and do this. You can go the layers and see the values here, apply only one layer and see how is your output. It's very good to do that. Now there is also another function to import. The new function in 2023B is the release I'm running here, the latest one since September. Import network TensorFlow. So we're gonna use this later. Now let me do a full image reading for you to show you how it runs. Okay, so this is data set path. If you have MATLAB toolbox, deep learning toolbox, you're going to have access to this network, to this data. So here I'm importing one image that is this 28 by 28 digit. Is the net is here. The input size is 28 with one dimension. Now I want to classify. So the way we do it is just running classify, and the result of my image is 5. The label is 5. What is the label here? Label 5. It's a categorical value. Okay, so what happened in here? We import a TensorFlow, basic one, okay, as a network, and we visualize the architecture. We read a new image and we run it, okay, as simple as we run in MATLAB. Classified, net, and the image. And here's the output. Now, MATLAB calling TensorFlow model for image classification. So now it's a bigger image. Now I think we have an image of let me see the size. Image is banana here. I don't know the size. Let me see banana. It's 1000 by 756. Here's the image. So now let me run this code. So image read banana, and here's the picture. But in this network, the only way to call it is you need to resize it. So the input is 408. Okay. So what we need to do, we need to resize the original image that is here. Original image. You can see the size in MATLAB is 3 dimensions, 700, 1000. We need to reduce it to 400. So now we see 400 here, the same image. Now, another step that you need to pay attention. TensorFlow orients image data in different formats to MATLAB. So this requires conversion. So high, width, channel, and number, you need to permute to number, height, width, and channel. It's here. Okay, so what is it stands for? Height, width, channel, and numbers. So you need to use this function before entering the image in the TensorFlow. So just change the dimensions, and that's all. That's all you need to do. And the inputs of TensorFlow requires to be integer of 32. So here is the integer 32. You just convert batch size of this. Now, how to bring the TensorFlow directly running in MATLAB? As you have installed TensorFlow in your libraries, right? In one of the Python libraries. So you call the same way you call when you import the applications. So TensorFlow cares applications efficient net we're going to run and the model. So here we will use also NumPy to convert the MATLAB array into Python array. That is the input for TensorFlow. Now we're going to call preprocessing functions that is required for the image input in Keras. So there is a preprocess input, and we will use the model to predict the image. And we will get the labels. That's going to be the prediction, the code, the same way you do it in Python. And the label is stored in a nested cell. So you have all of these nested cells of ID, class, and probability. So we just want the name of the label, okay? And convert it to Python string to MATLAB string. It's just provided as a string. Let me just run this. Okay, it's getting the model, doing the prediction. He's give you the modular prediction. 5 seconds took this one. And the output is banana, okay? The banana that is correct. You can see all these variables here. Let me see. Label. Okay, well, label, we did it. The label is here. But let me do it again. Now you can use this debugging in MATLAB. So before running this label, let me see what's here. So I will stop here so I can rerun this section. I want to show how is the label output in Python. Okay, it's there. So now it's a list, a Python list. If you go there, look at how is the output. ID, the label, the probability. So 81% of being a banana in this picture, and orange, and there are other outputs, pineapple, but they are very, very low. So now here we can continue step by step, and we'll be able to get only the label, for the first one. Second output, that's the name, okay? And continue. So this is one way. Maybe if you want to minimize the calls of this TensorFlow, calling TensorFlow multiple times can introduce overhead moving the library loading, and preprocessing into a TensorFlow script will reduce this, okay? So now, instead of calling directly the Python, you can bring this function here in MATLAB. For example, here I have my TensorFlow inference is this code. So in here I load the model, and also I have another function, and I want to return only the Y. So it's the same way you import TensorFlow, NumPy, and from this TensorFlow import the network, the preprocess function, and the decode prediction. So now we go to MATLAB. This is faster. You can then run in the one before. The first time you run it, maybe it takes a while, but after it's very fast. Okay, so the banana is here. The same way converting the labels. Now, you want to do batch processing of images. Now, instead of one image, I want to do thousands of images that I have in my folder. You can do that. So in this case, I have an image data store I'm using. So it's a way to call the location of the images in MATLAB. And I have a folder called merchant data. This data is from Deep Learning Toolbox, okay? So if you want to know the data set you have in MATLAB, Deep Learning data sets, you see it here. This is the website. I can go there, copy this. Let's go to the documentation, paste it, enter. And let's see what appears here. Data set for deep learning. You have a lot of data sets ready to use. This, for example, is the digit that we just use it. But some of them, they will download it. You have the script here. You just run this script. Because they are quite big ones, 200 megabytes. So we don't want to to load your storage of your computer, so you can download it, the data wherever you want. If it's already there, if exists the folder, will not do it again, okay? So once only. And more, you see data sets. We're going to use this one today. Merchant data are just products from MathWorks. Let's go back. Now what's going to happen? I have my prediction function inside a file. So I'm going to do around, let me see, merchant data, a lot of images here. So image, you see the spotlight, you see the screwdriver. Okay, so I have multiple images. Let me run this. So it's spending some time on the while loop. So has data means if I still have data in my image data store, run it. So you see, and I don't know, I think it's 4 folders. That's why maybe we'll take 4. Let's see how many images we have there. Image, so it's still running. Okay, finish. So let me see how many images we have in this data. Transform, okay. It's CSV text. 75 images, okay? And here are the locations of the images. So in data store will not bring the image to the memory. You will tell where is the image and bring the image to do the prediction. And after you delete the image from the memory. So doesn't matter your computer, you can run these very big models using data store. Executed in this case, right? Training is you require a GPU. So here's the spotlight is the output, the first one only took. Now let's go for the MATLAB exporting a network to TensorFlow. Okay, so if you have questions so far, please use the chat. We will answer the questions there. So exporting. MATLAB can read directly TensorFlow models and import and export. So on and X models, the one is I just showed you, this neural network exchange format. You can import and export as well. And PyTorch, you can import, okay? To export, you can export this on an X. So here are the converter functions. Let me just make it bigger, this. So you can download the toolbox called on an NX model format. Support package is free to use. There you're gonna find the import functions. This is if you have before 2023 B, so A and previous releases is this way. And if you have 2023 B, I have it here. You can use directly functions in MATLAB. You don't need to install this deep learning toolbox converter. So how to find this? You go to Home, Add-ons. If you have internet connection, it's here, it will connect to internet. It's the fastest way for you to install the libraries. If you don't have the library, it will tell you, okay, you need to install it. So you go to here and you can write on and an X, and it's going to find the deep learning toolbox converter. You click here, and for you will appear download and install. You can click install. I already installed it, and here's telling you the requirements you need to have. Deep learning toolbox is required, and since when was created, and the compatibility. Okay, so it's easy. You can go back, explore more toolboxes in these add-ons. Okay. Now let's go and use these functions. So now look at my network. I have this simple net on NNX. So this is the file extension you need to look for. So it's here. call it SimpleNet here. So you see, if you click, it's a file that is not readable. It's a binary file. You cannot read it that way. But if you use the import network from on an X file, you can see and plot what is in how is the network. So here's the network. It's 9 layers. Okay. And there is another way to see this network. If you have Deep Learning Toolbox, Deep Network Designer app. So you can run this function or go to apps. And here you can find inside machine learning and deep learning, the Deep Network Designer. We have more apps, quantizer, regression, classification. So if you open the Deep Neural Network Designer app, okay, it's opening, okay. Here you have the options to import, to have a blank one and create your network, import from Workspace, from PyTorch, from TensorFlow. There are some image networks pre-trained that you can download it. If it has this warning, means that you need to install it. It's not installed. Okay, just click here and you install easily. Okay, there are not only this one, there are multiples. Sequence networks as well for LSTM and the audio networks pre-trained as well. Okay, Mathur is adding more and more. So if you can import what is in Workspace, say it's unable to find it. Okay, it's not there, so we can actually import after creating the network, the layers. Let me go back. So now let's modify the network, okay, and export it. So you can download the SqueezeNet that I already have and the layer graph. Now we can go to Deep Neural Network, and there we will import sgraph. The graph is here, okay? On the network also you can import it. Okay. And look, you can see the layers. So it's very small, right? But you can just zoom it, control and zoom it. So you'll see the networks. This is a deep learning network. It's called deep because it contains so many layers. Shallow is the neural networks. You don't need to worry about, but this is a lot of processing. If you go to the convolution, you'll be able to see the parameters here. It already contains the weights and biases. You can see more inputs here, more layers, sorry. And you can analyze these networks. And if everything is correct, the layer to another layer is correct, you will have 0 warnings and errors. It's going to show you the layers that contain the learnable parameters here and here, and where it's located as well. Here, fire squeeze, and you can go here and see what is the layer. So it's very user-friendly to see what is inside. It's very helpful. Now, let's go back to MATLAB. Now what we want to do is to modify the layer, okay, and export it back. So here we analyze already the network. It's when you do this analyze directly, we'll open the same we open in the app. Look here, we have 1.2 million learnable parameters. When you see ChatGPT, ChatGPT is using GPT 3.5, or yes, but I know the number of parameters in GPT 3 is 175 billion. So many parameters. That is very difficult to open it because it's very big file, terabytes of data probably. Okay, so now we can export it. So I want to export the graph directly to on an X. Look, it's exported here, layers 1. So you import it, you can modify it and export it. So let's modify. Let's remove one layer and analyze it. Okay, let's remove the last layer. Okay, So now it's giving me the error. So look at this error. There is a missing output layer. Network must be at least one output layer connected, and it's not connected. So if you go to the end here, here's the error. There is a missing layer. Now, so I also have the image here, but also I exported that way. Okay, it's here. It's 2. Okay, I want to fix that. So I want to fix it. You can open it directly on Deep Learning Toolbox app here. So new, import from workspace. This one with 7 layers. Replace it. Let me see. Let's go to the last layer. So it's finished in softmax, but it's a classification one. So we can go to output layers here. Here, output, classification. Now, before bringing it, let me show you the error. Analyze. Error, okay? Now let's bring the classification and connect it. Now let's analyze it again. Okay, 0 errors. Now you can use this for training. Okay, 1.2 million as well. Okay, let's go back to MATLAB. Now let's run. No, we did this. Okay, import the pre-train from TensorFlow. So also this DAGNetwork, we did before, but now we are using this import network from TensorFlow. Okay, a different function. This is only available from 2023. B. Now let's go for export TensorFlow network. So now we use this export network with the file, the network name, and the file name we're going to propose. So it's going to call exported. So we have it here and we export it. It's here, you see? Very, very fast, you can export these networks. Now, I want to run a model in Python, a model that I already have in Python. So you can edit the Python script as well. If you just use edit, you will be able to import and edit here. You can edit directly here. Okay, so here you have an import TensorFlow and you're using keras and layers, and you see the layers here. So 68 layers, and return the model. So you can go back in MATLAB and use this model. Okay, so now create a data test for Python to use for evaluation. So I'm creating data test in MATLAB. Okay, so you are using random numbers here. I want to predict, and I permute because I need to modify the dimensions order, and save as data test. So it's inside my save model here. If you go to data, you have test. Okay, the data test is here and the model is here. Now I want to compare results. So I already saved the results before, and here we see that if I run it in MATLAB, this is test in MATLAB and test in TensorFlow. Here you see the error is close to 0. It's minus 0.0001. See, it's very small. So it's the same result that I want to show you. Okay. And import PyTorch model from network. So also you can use the functions to import this. So save the PyTorch model. We're importing this MNAS network. This is the author of the network. And let me just see here. Okay. It's called PT now. You see, instead of PB, now it's PT. You import that using the import network from Torch. You can modify the file as well as we did it before, and you can analyze it. PyTorch. And here you see the PyTorch one, okay? It's a very long one, look at this. It's so many layers, I don't know how many, let's see. 153, 4.4 million learnable parameters, 153 layers. Okay, and analyze, okay? So this is the script I have today. I will have a, if you want to learn more, there are links for cheat sheets using MATLAB and Python. You will receive this file, just email us and you'll receive this file. Calling Python from MATLAB, the documentation. Always go to open documentation by clicking here, help. And inside MATLAB, you can go to external language interfaces, C++, Java, Python, .NET, COM libraries, web app services, C, Fortran. So we can go to Python and call Python from MATLAB or MATLAB from Python. So you decide. So we are doing this. And you see a lot of documentation here, how to use Python libraries in MATLAB, run Python code, pass in data. So we did something like that in this webinar. Troubleshooting errors if you find, and examples. Examples ready to use, okay? You click here and you can just open the script and you have the documentation. We'll go directly to MATLAB and open the script, okay? And yeah, let me go back to the slides. So we saw these different ways. Now let's jump to the calling MATLAB from Python. So MATLAB works as it's called MATLAB Engine API inside Python. So when you open Python, you can bring MATLAB inside Python and use the functions from MATLAB there. And also you can communicate with MATLAB using this process ID I showed in the beginning. So MATLAB and Python, you can call, exchange data, and do so many different things. So here's how you need to install the Python for MATLAB. There's in the documentation. The same way you do it, you go to pip install MATLAB engine and we'll install this, okay? So you call this way. After you import MATLAB engine, make engine as MATLAB engine start MATLAB, and call the functions engine dot the function in MATLAB for a square root of 4. The answer is 2. When you finish, you can just write engine exit, okay? That's simple. So you can create and terminate MATLABs. You can put variables into MATLAB's workspace. You can get variables from MATLAB workspace, call MATLAB commands synchronously and asynchronously. And Python data types are implicitly converted to MATLAB data types. So you need to pay attention on that. We have almost all the data types. The only thing we need to see is between double, integer, and now MATLAB have dictionaries like Python, lists. You can use all of this, okay? Now about the deployment for Python or any other programming language. Let me show you how it works. Sorry. So Python, the deployment and scalability of MATLAB, you can bring productions, any MATLAB other codes like Java, .NET, Python. In this case, we have Python. You will have, you can have web applications, Excel add-in, application server, so web app server. So there are multiple ways to deploy your MATLAB code, your Python code, C code, and Excel add-in as well, okay? You need to use this MATLAB compiler SDK product. And so, summary of what we did today, it's calling Python from MATLAB. We did this script, calling MATLAB's analytics from Python. You can do the same. It's shown in the slides, and packing applications for scalability deployment of Python in production. So there is a lot of content for you to learn more. So we have MATLAB for free, how to learn on ramps, Simulink, machine learning, deep learning, reinforcement learning, image processing. So it's very important for you to go there. We have more than this actually. Simscape is here, okay, we have more. And just go to MATLAB Academy, mathers.com. The only thing you need is a Mathers account. Advance your skills. So we also have a course by topic, data science. These are trainings. There are paid trainings. Some of them are self-paced directly on your MATLAB. Some of them you have instructors. Okay, so this also is available on the trainings. And additional resources. So go to Python and MATLAB. It's a discovery solutions page that you have a lot of workflows there for analytics, predictive analytics, and deep learning. Now, thank you for attending. We have 10 minutes for questions. Follow up more content. We have a website, setsimulation.com. There we'll post many of our events, and you can also access our YouTube channel. We have different videos about how to handle MATLAB and Simulink with Python, with other applications as well. Follow us on LinkedIn, and because there we'll post the webinars invitations as well, so you can enroll it. And anything you need now after this presentation, please email us to support@setsimulation.com. So there we can request your script. Okay, just tell us your name and where is your company and what is your objective. Is good for us to know more about you. And sales@simulation.com if you are looking for a quote of MATLAB